and welcome to our next video in this Integrated Math 1 video series. In our last video, we talked about substitution. So if you haven't watched that yet, make sure to go back and do that. In this video, we're going to talk about something called elimination. But before we do that, let's go ahead and do these 4 bell work or warm-up problems, and then we'll go from there. All right, so in this case, last video we talked about drawing a system with no solutions, and we had to draw 2 parallel lines to indicate that. If you draw a system of equations that has infinitely many solutions, so if 2 lines share infinitely many points, that means that they're the same line, right? So really, your graph would look something like this, and then you would just, of course, you would draw another line like on top of it. So they're the same line, right? So you may actually not even see both lines in some ways. You'll just see one line. So there are 3 types, right? There's no solution, which we saw earlier with parallel lines. There's one solution, and then there's infinitely many solutions. Those are the only 3 types that you could run into with systems of linear equations. Later on in future courses, you might try to find the intersection of other types of functions that could intersect more than once. Anyways, those are the 3 for linear functions. Number 2, what is 3% of 21.3? Let's multiply the 2 numbers involved, 3 and 21.3. See, 3 times 21 is 63, and then 0.3 times 3 is 0.9. And so it's either going to be 63.9 or 6.39 or 0.639. It's not going to be 63.9, right? Because that would be way too much. We need a really small amount of 21.3. So how about 6.38 or 39? Still too much, right? That's going to be a third, 30% of 21.3. And so let's go one more time. 0.639. That's going to be 3% of our number there, 21.3. Number 3, and this is going to kind of help us lead into what we're doing today, simplifying something like this. We're going to distribute the 3 into here and the negative 2 into there. So 3 times x is 3x. 3 times 2y is going to be 6y. Negative 2 times x is negative 2x. And negative 2 times a positive 3y is a negative 6y. From there, we can actually combine like terms. 3x minus 2x and 6y minus 6y. So 3x minus 2x is just going to be 1x. And then 6y minus 6y is 0 y's, right? So nothing. Those are what we call additive inverses. So we're really just left with x. All right, so again, that's going to help us with what we're doing today. What is the solution to the system graph below? Hopefully, let's see, here's the origin here. So hopefully you can see that the solution is, let's see, looks like 4, negative 4. So the point 4, negative 4. And it was this system here that we were looking at here. All right. So if that's the case, if you have a system like this, you can use substitution like we did in our last video. However, you're going to be dealing with a lot of fractions and things, and it's not as easy to solve for any of these variables. So what I'm going to show you today is how to use something called elimination. For me, in my preference, I prefer elimination over substitution in most cases. Now, if you've already got a variable that's by itself, like y is equal to something or x is equal to something, then I'll probably go substitution. But for me, my preference is elimination. So I want to show you that here today and see what you think about it. All right, so let's get into kind of the reasoning behind elimination before we get into the actual strategy here. Just as we talked about last video, we're going to talk about age. So Jamie, we're given that Jamie is the same age as Tim. So that is true. We're given that as a fact, okay? It says, which of these must be true. So given this, which must be true? So if Jamie's the same age as Tim, would Jamie's age times 2 be equal to Jamie's age, or Tim's age times 2? Would Jamie's age plus 7 be equal to Tim's age plus 7? Would a third of Jamie's age, so 1/3 of Jamie's age, be equal to a third of Tim's age? So take a second, what do you think? Hopefully you're saying that yes, all of these will be true, because we're doing the same thing to both people's ages. And so, of course, these further statements are going to be all true. All right? So that means that if we have A is equal to B, that means that 2A is equal to 2B, and so on, right? A plus 7 is equal to B plus 7. Right? As long as we do the same thing to both sides, then we have an equivalent statement, right? Given what we started with, the equation we started with. So that leads into our next point here. So we're assuming A is equal to B and C is equal to D. So that's what we're given. So if that is true, what do you think here? Is A minus C equal to B minus D? Let's start with that one. So we started with an equivalent statement. Did we do the same thing to both sides? And you might be thinking, no, we subtracted C over here, but we subtracted D over here. But aren't C and D the same thing? So yes, we did do the same thing to both sides. So in fact, this is true. So this is true. And one way to look at it is we just subtracted this equation minus this equation. So left side minus left side, right side minus right side, and we got this new equivalent statement. This is a true statement now. All right, what about this one? What if we have 2A plus C and 2B plus D? Is that true? Well, let's see. We've said before that we can multiply both sides by 2, right? In the last slide, we said that, right? Well, 2A plus C and 2B plus D. Well, we know that 2A and 2B are the same. Did we do the same thing to those quantities? We added C over here, we added D over there. Those are the same quantities, right? So yes, we did the same thing over on both sides. And so yes, this is true. So basically, some things that we can walk away here with is, in this first one, we can subtract the first equation minus the second equation. And in the second one, we could also multiply one or both equations by a number, and then either add or subtract the second equation from there. So there's a lot of different things we can do in these situations. As long as we do to one side, the same thing we do to the other. So let me give you an instance in terms of what we're actually going to get into with this. This is a system of equations. These are in standard form. And you might be thinking, it wouldn't be too bad to do substitution, right? Because you could solve for this y value maybe, and then substitute what you get into the y value down here and then solve. But let me show you elimination, okay? So going back to the last slide, like this is A, this is B, this is C, this is D. All right, so what we know is that we could either subtract the two equations, we could add the two equations, we could even multiply one or both equations by a number throughout the entire equation. But what we want to happen here, here's our goal. Our goal is to eliminate, hence the word elimination. We want to eliminate one of the variables, meaning when we either add the equations together or subtract the equations together, we want one of the variables to be at 0, to be gone, okay? So think about this. And this will come with time and practice, but what's going to be easiest here? All right, if we add the x's together, we're going to get 7 x's, right? That's not going to help. If we subtract the x's, 4x minus 3x is going to be 1x. That still doesn't eliminate x. But let's go to y. What happens when we add the y's together? Y plus a negative y, so be careful with your negatives here, because you're actually adding the two equations. Y plus a negative 1y is 0y. So that means that y is eliminated from this new equation that we're building. All right, so that's going to be what we need to do here. If we were to subtract, and you think subtraction works, y minus a negative y is actually going to be a plus y. So if you were to subtract the two equations, you'd get y minus a negative y is a plus y. So it'd be y plus y is 2y. So that's not going to work. So that's why we're adding, and I'm just going to put an addition out here just to remind me that I'm adding these two equations. And so we're going to have 4x plus 3x is 7x plus y plus a negative y is 0y. So I'm not going to write it down here. And then don't forget to do it on the right side as well. 5 plus 9 is 14. So x is equal to, if we divide both sides by 2, x is equal to, we're divided by 7. Got ahead of myself there. X is equal to 2. See how simple that was? If we added the two equations together, we eliminated y and we were able to solve for x. X is 2. That would have taken a little bit longer had we used substitution. All right, so now that we know that x is 2, we can use that to solve for y. Just like we did with substitution, we're going to substitute that back into one of the original equations, maybe the top one here, 4x plus y equals 5. We know that x is 2 now, so we can put that in here. So we have 8 plus y equals 5. Subtract 8 from both sides. And we get y is equal to negative 3. So the point 2, negative 3 is the solution to this system. And we were able to do that pretty quickly using what's called elimination. All right, so let me show you one more here that you're actually going to need to multiply one of the equations by a number. Because right now, there's nothing that automatically eliminates here. We can't add or subtract the x's to get 0. We can't add or subtract the y's to get 0. So we've got to multiply one of the equations by a number so that that does happen. Okay? So think to yourself, what would you multiply by and why in order for that to be the case? All right, really I see two best options here. The first one would be to multiply the whole top equation by negative 3. I hope you can follow me here. If we were to do that, negative 3 times x would be negative 3. So when we add the two equations together, x goes away. X is eliminated. All right, now y is not going to be, and that's okay because that's what we'll end up solving for. But that's one option, is to multiply the top equation by negative 3. So if that's what you said, great. One other option is to multiply the bottom equation by 7. All right, if we do that, we're going to get 21x here, so we'll still get some x's, but look what happens to the y. 7 times negative y would be negative 7. When we add positive 7 and negative 7y, we get 0. Okay, so either way is fine. I'm going to go with the first option, which was multiply the top equation by negative 3. So if we do that, we're going to get negative 3x minus 21y equals negative 3 times 2 is negative 6. On the bottom equation, we still have the same thing, right? It hasn't changed. Now, if you need to multiply both equations by something, you can. But in this case, we're able to get that done with just one multiplication. All right, now we can add these two equations together. We're going to get 0x here, negative 22y, and negative 66. So when we divide by negative 22, let's see, 3 negative 22's go into negative 66. So it'll be y equals 3. All right, so we know that our point is something, comma, 3. And we can take that 3 and we can substitute it into either equation. This one's probably going to be easiest because this y doesn't have a coefficient with it. So it would probably be easiest to put 3 in there. So we get 3x minus y, which is 3, equals negative 60. From there, we can add 3 to both sides and get 3x equals negative 57. Yeah. So we're going to divide both sides by 3. And we get 19. So we negative 19. So that's the x and y that satisfy both of those equations. It's kind of like elimination is almost like a little bit of a puzzle, right? To figure out how can I multiply one or both equations so that when I add them or subtract them, one of the variables is eliminated. So it's kind of to me, it's kind of fun to kind of figure out what works out for that to happen. If we look at our solution here, we said it should be negative 19.3. So negative 19 right here, comma 3 is our solution. So we're still finding the intersection of the two lines. We're just doing it algebraically in a different way than what we did last video. Okay, so let me give you a minute to try one. So to take a second and try to do this problem. All right, so there are, again, 2 different ways that I would recommend doing this one. Either multiplying the bottom equation by -4 or multiplying the top equation by -4. Either way is going to work out just fine. All right, I'm going to multiply the top equation by -4, and that's going to end up eliminating the y values here. So let's see. We're going to get negative 16x minus 4y equals, let's see, negative 4 times negative 5 is 20. Down here we still have x plus 4y equals 12. So now we can add the 2 equations together. So we get, let's see, negative 16x plus 1 will be negative 15x. 0 here equals 32. So divide by 15, negative 15. And let's see. We're gonna get 2.13 repeating, which hopefully you recognize that value from our last video. This is actually the same problem we did in our last video. And again, elimination a little bit quicker here if you're able to figure out how to eliminate one of the variables. And then you can substitute 2.13 repeating, and for the x, I'll go here. So 2.13 repeating plus 4y equals 12. And we can solve for the y value. So 4, we're going to subtract 2.13 repeating, both sides. So we get 4y equals, let's see, 12 minus that value is 9.86 approximately, 9.86 repeating. And then we're going to divide both sides by 4 and get y is equal to, so I'm just going to hit divided by 4 on my calculator here. And we're going to go, let's see, 2.46 repeating. Which, let's see. Hopefully you got this. I noticed that this value isn't the same. When we divide here, this should be a negative 2.13 repeating. I apologize for that. So let's fix that here. So it's going to be negative there, which means we're going to add 2.13 repeating to both sides. So I'm going to go back up here, change this to addition. So 14.13 repeating. Divided by 4 gives us 3.53 repeating. So we have the point negative 2.13 repeating, comma 3.53 repeating. All right, and again, that's the same picture as last time. Negative 2.13 repeating, comma 3.53 repeating. There is our intersection point. All right, so again, let me give you a minute to try this one. Okay, so in this case, we actually don't need to multiply either equation by something. We can actually just subtract the two. So if we subtract the two, so because y minus y would be 0. Y minus y would be 0. The other way you can do it is you can multiply the bottom equation by like -1 or something and then add the two equations. Either way is fine. So 2x minus a -3 would actually be a +3. 2x plus 3 is 5x. And then the y's are eliminated. 9 minus -1 would be a +1. So 9 plus 1 is 10. So if we divide both sides by 5, we get x is equal to 2. So pretty quick there, right? Even though we could have used substitution fairly easily as well, in this case, we could just subtract the 2 and get our first solution pretty quickly. Now we can substitute that back in, maybe up here for the x. So we have 2 times x, which is 2, plus y equals 9. So 2 times 2 is 4. So y, when we subtract 4 from both sides, y is 5. So we have the point 2, comma 5, which again, I think we did in our last video as well, this one. So I'm trying to show you the difference between substitution and elimination with the same problem so you can see which one you like best, but also when each one is beneficial to do. Again, graphically, we see the same point we saw in our last video. Okay, here's the one I really wanted to show you. Again, we did this in our last video, but the difference between substitution there and elimination here. So I believe we had, let's see, Emily had the vortex 3 times, plus the gravity breaker twice, and that was equal to 14. And then let's see, Troy spinning vortex twice, and the gravity breaker 3 times, equaled 16. So we solved this using substitution in our last video, and it was a little tedious, a little time consuming. So I want to show you how to do this using elimination. Right now, this does not work out well with addition or subtraction. We've got to multiply our equation or equations by a number. So take a second and see what you can do on this one. You're going to need to multiply both equations by a number. You can multiply the top one by a certain number and the bottom one by a different number, but you're going to have to do both in order for these to subtract or add together to give a 0 using integers. All right, so take a second and see if you can do that. All right, so in this case, you can multiply one of the equations by like 3 and the other one by 2 or something like that. I'm going to multiply the top one by 2 and the bottom one by 3. So if we do that, that's going to give us 6v plus 4g equals 28. In the bottom equation, we're going to get 6v plus 9g equals 48. Okay, so notice what happened now. I was thinking about the v's here. 2 times 3 is 6, and then also 3 times 2 is 6. I wasn't worried about the g's. You could have done it with the g's here, but I chose to eliminate the v's, and the 2 and the 3 multiplying there will do that. So you can multiply both equations by a different number, and then either add or subtract the equations afterwards. So here, we're going to actually subtract, right? 6v minus 6v would be 0, which is what we want to happen. So we're going to subtract the 2 equations. Maybe I'll do this in red here. Subtract the whole equation from that whole equation. So 6v minus 6v is 0. 4g minus 9g is negative 5g. And then 28 minus 48 is negative 20. So dividing by negative 5 on both sides gives us a value of g of 4. Which, if you remember from last video, that took us a long time to get to that point. All right, so now what we can do is we can take that g and substitute it back in for a g up here. So we're going to get 2v plus 3 times g, which is 4, equals 16. So we're going to get 2v plus 12 equals 16. Because 3 times 4 is 12. And then, of course, we're going to subtract 12 from both sides, giving us 2v equals 4. Divided by 2 gives us v is 2, just like we got in our last video. So from there, we can figure out what Roger needs. Roger's doing the vortex 4 times, so 4 of these. So if he needs 4 sets of 4, he's actually going to need 16 tickets to ride the vortex 4 times. The gravity breaker 5 times, so it would actually be 20. Sorry, four sets of 5. So the gravity breaker 5 times, so 5 times 4 is 20. And then the vortex 4 times, which was 2. So 4 times 2 is 8. Add those together and we should get 28, just as we did in our last video. So, but you can see the difference here. So all in all, you need to kind of figure out what strategy you like best between graphing, substitution, and elimination based on the situation you're in. If it's easy to isolate, meaning get by itself, one of the variables, then maybe substitution is better. If you've got y equals something and y equals something, then transitive property, you can do that pretty quickly using substitution. If one of the variables is not easy to isolate, meaning maybe it's got a coefficient in front, so you have to use some fractions, that kind of thing, maybe elimination is the way to go, where you can either add or subtract the equations. You can multiply one of the equations or both equations if necessary to eliminate one of the variables rather quickly. So hopefully that gives you an overview though of our 3 methods: elimination, substitution, and then also the graphing perspective as well. All right. In our last video of this unit, we're going to look into solving systems of linear inequalities, which is similar to systems of equations, but involving less than and greater than and that kind of thing. So hopefully you'll join us